Okay, we're going to talk about engineering projects, design projects, needs identification, and problem statement. Here you can see the learning objectives of this presentation, of this lesson. At the end, you will have an understanding of the types of projects that electrical, electronics, and computer engineers undertake. Have an understanding of research and development, R&D projects, will know how to determine the document and rank end user needs, what we call needs identification and problem statement. And you will be aware of resources for conducting research service and will know how to state a problem. Okay. The objective of a design project is to create a new system, process, or component to meet a given need. Here, the need is critical. And there may be different design categories. Here you can see basically the three categories of design: creative design, variant design, and routine design. In creative design, we simply develop something new and innovative. An example will be Palm Pilot, which was a very popular device, and it was simply a handwriting language that the Palm company had developed. And for variant design, we have an existing design or system or component, and we simply try to improve the performance of the system or design or add some new features to the design. Actually, many of the engineering projects fall into this category, variant design. Finally, we have routine design, where we have very well-known theory and many practices, and would like to design a device, just like, for example, a power supply, a filter, digital or analog, or amplifiers, let's say. Usually, written designs are components of creative or variant designs. There are many types of projects, engineering projects, based on the design concept we have described in previous slide. One will be systems engineering integration. These are large-scale projects involving many peoples from many different disciplines, and it could be synthesis of many systems or subsystems into a larger system. There may be any type of design that we have discussed in previous slide in this type of engineering projects. We usually work with many different engineers from many different disciplines in such projects. Testing is about an existing system, whether it meets the requirements or not, or it meets the needs of the user. It is quite popular in space and military applications where testing is quite critical. In experimental design projects, we are usually expected to develop an experimental procedure for an apparatus for determining the characteristic of a system. So we may, for example, ask to test the system under a variety of operating conditions. Analysis projects. In analysis projects, there is an existing system again, and would like to improve or correct failures in the system. So we need to analyze some aspects of the system. Technology evaluation projects. For a given application, we may be asked to evaluate whether a new technology can be used in that application. It may improve the any existing system in that application, or simply characterize its operating performance. Okay, engineering research projects. So we categorize design. We simply classify or give the types of engineering projects. Now let's see engineering research projects. In research or research projects, we would like to discover or create a new technology or a method. So we perform research or experiments to do this. And usually the ultimate outcome in such projects is unclear or unknown. So there is an ambiguity about what we are going to get at the end of the project. Engineering research projects, R&D projects, falls into three categories. The first two are discussed in the textbook. The last one is not given. The first one is fundamental research or basic research. It's about new scientific principles that we'd like to discover, and there is no targeted application in such research projects, but they are very valuable, especially for long-term developments. These are not typically type of or part of design projects. Applied research, usually engineers somehow perform such research projects. These are about creation of a new technology or a system based on some existing technology and theory developed from the fundamental research that we have discussed here, basic research. So that is one step further of fundamental research. Experimental development is a systematic work that aims to produce some additional knowledge, usually based on some experimentation. And the target of these projects is some new products or processes, or improvement to existing products or processes. These are quite popular in many of the funding organizations. And you can see Frascati Guide, which describes research and development, and OECD, NSF, and TÜBİTAK programs are highly based on this type of projects. Okay, we always start with needs identification in many of the engineering projects. So in our course, we start with needs identification. Here, needs usually are somehow introduced by customers or a client or a supervisor or your team leader or your instructor. In this case, for example, in our course, I will describe the need. We simply say the voice of the customer. The voice of the customer is critical. We should understand what the customer needs, and we have to study the need and then talk to the customers, conduct some research, and then we switch to the next stage. Here on the right-hand side, I'm showing a map. You can see train station right here, and we are here, electrical electronics engineering, and here is the engineering faculty. And I got a problem as a faculty in this department. Whenever I drive out to the faculty, I always get somehow a traffic congestion here because there are three different directions, three different traffic flows, and they intersect somewhere here, and it may not be safe. So this could be a need, for example. Here, I simply say my need. The traffic at the campus gate is not safe. That is F gate, port gate, what we call, and mostly congested. I'd like you to redesign the traffic flow at the campus entrance. So this could be a very good customer need. Here, I will be a customer, and that's a very realistic problem, and I have a very important need here. Anyway, this has been studied carefully by the faculty, and then there has been a solution, partial solution here. So I'd like to thank our dean and administration for this, but there are still some problems here. Okay, so needs identification. Here you can see the steps to obtain the voice of the customer. We are given a need like this, for example. Next, we should gather some raw data. We need to interview with the user. So if we go back to the problem that I have described in previous slide, then the administration should interview some other professors here, maybe, or students here. And then in some applications or needs, you need to focus on some groups. You should observe what is going on in problem side. For example, this could be gathering raw data stage. Next, we interpret the raw data in terms of needs. So here we can think about commercialization. So we have to think about marketing if there is a product, if we are targeting a product. And we have to think about market here. And this goes to marketing requirements, so specification of marketing requirements. This is the second stage. Next, we organize the needs into a hierarchy, what we call objective tree, from general to specific. So this is about functionality, actually, of the product. We next rank the needs with this hierarchy objective tree. We weight the elements and then at the end rank the need. Finally, we review the outcomes we obtain from steps 1 to 4 and make some decisions. Okay, here you can see hierarchy of needs, objective tree for a project, portable audio device. It may not be a new, of course, but a new device, but we can imagine that we are given a task or we have a need to design a portable audio device. And then for marketing, from marketing point of view, we can think about portability here. This could be an important function or property that we have to consider. Portability, easy to use. So if you want to sell this, it should be easy to use from the user point of view, and high quality audio. So we simply give some weights here. The total should be 1. So 0.14, 0.62, 0.24. And for high quality audio, we split that into low distortion and low noise. These are the parameters that are used to define how your device meet this high quality audio requirement. Again, we weight this 0.67 to 0.33, which makes 1 total. We again split portability into three sub requirements, let's say, and then three requirements for easy to use. So we weight each of these and then simply determine objective three for our product. Research surveys plays a key role for concept development stage. We need to conduct a literature survey and try to understand the knowledge available there, find existing components or devices similar to one that we want to develop, and try to understand practices there and technology available for use in our design. We usually use internet search, some textbooks, some journals, conference, websites where technical or other details of the system or component are provided. Here, this research survey is very critical. We have to be careful, not spending money for reinventing the well, simply. So it's very important to conduct a comprehensive literature survey. At the end, we refine the project concept based on the findings from this literature survey. Questions that could be asked in research surveys are listed here. What is the basic theory behind the concept? How is it currently being done? What are the limitations of current designs or technology? What are the similarities and differences between your concept and existing technologies? And are there existing or patented technologies that may be relevant to the design? If so, what are they and why are they relevant? So this could help us to evaluate our concept or our approach. In research surveys, there are many resources, as I stated in my previous slide. Internet is, of course, the major tool or way to find those resources. Here you can see some of the websites where you can find materials regarding with projects in electrical electronics engineering. Here you can see patent search links in Turkey, US, and in general. And here you can see the journal and conference, databases where you can find the journal and conference papers. IEEE is a very important resource for electrical and computer engineers, and Web of Science could also be used. For this, you need to use Gazi University Library, from which you can have a free access to those databases. Okay, then let's see this statement. It should be brief and clear, and it should state the need to be met. We do not provide a solution to the problem here when we are stating a need or need statement. We provide some supporting statistics or anecdotes. We describe current limitations and we describe supporting processes. Here you can see an example of need statement. It's about iPods, and here some statistics, as you can see, are given based on some research. And here a problem or the weakness is described. iPods can present a distraction to drivers that's similar to cell phones. So this could be the point that we have to consider. And at the end, a system is needed to allow users to navigate among the music selections of the iPod without distracting their attention from the road. So this is for drivers. Here you can see needs statement from a project in previous year's E392 course. Here you can see the customer need from previous year. It was a waveform generator, arbitrary waveform generator, within the range of 1 Hz to 50 megahertz with a peak amplitude of 5 volt plus minus 5 volt. And it's expected to generate sine wave, triangular wave, soft waveforms, and it should be controlled by smartphone. So this was the customer need, and I was the customer. I had, of course, also the supervisor or instructor cap at. Here you can see the need statement from a project. This is what students have written simply. This could be discussable, but it shows the capacity and what students understood from needs statement when we consider previous year's projects. Objective statement. Here we summarize what is proposed to meet the need. So there is somehow concept that we have to describe. And there should be some preliminary design objectives. There is not much detail here. And we describe our solution in general by giving input-output behavior of the system and try to avoid details, not to give details here, not to give complete solution, because we do not have complete solution usually at this stage. Here is an example of objective statement. Usually we start with the objective of this project is ... And this words here is quite important. Make the iPod safer to use, allowing hands-free control. See, these are some high-level design details, actually. Simple voice commands, for example. That's a way to develop a device and communicate information verbally. So these are some part of some components of the solution, but not details are provided. Here you can see an example from previous year's project, E392. Again, the customer need, yeah, and here what students or how students stated their objectives or provide their objective statement. This could be discussable. I'm not saying that that is a perfect objective statement. This may help you to develop your objective statement in the projects. Here you can see device objective 3 for the same project, the previous year's project. And the students have given some details on how they assign tasks and how they split the work into the members of the team. Here on the left-hand side, we got a task sharing and device objective 3 are simply associated with the members of the team. And finally, the problem statement. It should include all previous elements. So problem statement is a section, is a stage, and it has some components. Here you can see the components. We have to have a need. We have to describe the need, what we call needs identification, and we have to develop objectives, so objective statement, and we have to conduct a literature survey, so research survey, as we have described previously, what we call background information, and then we have to state marketing requirements, which goes to objective 3. So these two are somehow connected to each other. And then we complete the problem statement.